Hello grade 10 students. Welcome to video lesson number 10. I'm Madhu Vadke. We will continue our study in chapter 2, that is polynomials. In previous class we learned how to find out the zeros of a polynomial and verify the relationship of these zeros with its coefficients. In today's class we will learn how to form a quadratic polynomial when its zeros are given. We will also apply this knowledge in some problems to find the unknown variable. All concepts and questions done in video class are to be written in your notebooks along with the video class, like we do it in a normal classroom setup. So let's get started. So we will learn how to form a polynomial when we know its zeros or we know sum of zeros and product of zeros. To explain this, I will consider an example. P of x equal to 10x square minus 14x minus 12. First, we will find out the roots of this polynomial. We start by finding the factors of this polynomial. Notice that each term is an even number. So, we can take 2 common. We get 5x square minus 7x minus 6. So we have found one factor. We can further factorize 5x square minus 7x minus 6 by using sum and product that we learned in the previous class. To find the product, we multiply the coefficient of x square and the constant. So the product is 5 into minus 6, which is equal to minus 30. Now we have to find the factors of minus 30 in such a way that those two factors add up to the coefficient of x. So the sum is minus 7. So 3 tens are 30. And subtracting these two numbers we get 7. Now we need to place sign with one of these numbers so that the product is negative. So we'll place minus with 10, and we have to make sure that the sum of these numbers is minus 7 and the product of these two numbers is minus 30. So now splitting the middle term, this is equal to 2 times 5x square plus 3x minus 10x minus 6. Now we will find common from first two terms inside the bracket, that is x. So we are left with 5x plus 3, and from the other two terms also we will find a number common such that we are left with 5x plus 3 in the bracket. So you can see that minus 2 will be the common number. This is equal to 2 times 5x plus 3 into x minus 2. So we have factorized this polynomial. Now to find the zeros, we equate the polynomial to 0. So if the polynomial is 0, then its factors are also 0. So this implies 2 times 5x plus 3 into x minus 2 is equal to 0. So either of the numbers in the brackets have to be 0 for this product to be 0. So 5x plus 3 is equal to 0 or x minus 2 is equal to 0. So x is equal to minus 3 on 5 and x is equal to 2. These are the zeros of this quadratic polynomial. And 5x plus 3 and x minus 2 are the factors of this polynomial along with 2. So let's generalize this result. We will call one of the roots as alpha and the other root as beta. We have done this in previous class to find the sum and the product of the roots. So if alpha and beta are the zeros, of a polynomial p of x, that is a square plus bx plus c, then this polynomial can be written as k times x minus alpha into x minus beta. Let's look at what this means. 5x plus 3 and x minus 2 are the factors of this polynomial. So same polynomial can be written as product of these two factors, which then gives us the zeros. So if we know the zeros alpha and beta of this polynomial, the same polynomial can be written as product of its factors. It means that we are going backwards. If we know the zeros, then we can make the factors and then we can write this polynomial as the product of these factors. So let's simplify this. K in bracket will multiply the two brackets, so you get x square minus alpha x minus beta x plus alpha into beta. This is equal to k times in bracket x square minus will come out alpha plus beta in the bracket times x plus alpha beta. If we look at the bracket, which is the coefficient of x, we get coefficient of x as the sum of the roots. Alpha plus beta is nothing but the sum of the roots times x plus the constant of the above expression is alpha into beta, which is the product of the roots. Writing the other terms. So we have generalized a way of writing the polynomial p of x as x square minus sum of the zeros times x plus product of the zeros. So if we know the sum of the zeros and the product of the zeros, we can make this polynomial. So this is k times x square minus s x plus p bracket close. Remember, there is a minus sign with the sum in this format. Now let's apply these results. Find a quadratic polynomial such that the sum of its zeros is root 2 and the product is 1 over 3. Let's write down what is given. The sum is root 2, product is 1 over 3. We use the general form for the polynomial that we found earlier. X square minus sum x plus product. So substituting the numbers here, in place of sum we write root 2 and in place of product we write 1 over 3. So this is our answer. You can leave this answer till here, or we can also write p of x equal to k times x square minus sum x plus p. So on substituting x square minus root 2x plus 1 over 3. Here if we take k equal to 3, then our polynomial becomes 3 times x square minus 3 root 2x plus 1. So this also can be our answer. Both answers are correct. Second question. Find a quadratic polynomial whose zeros are minus 6 and minus 2 on 3. Here zeros are given, so we will need to find the sum and product. Alpha is equal to minus 6, beta is equal to minus 2 on 3. Let's find the sum. Minus 6 plus minus 2 on 3. So this will be minus 18 minus 2. That results in minus 20 on 3. Now we find the product. So alpha into beta is minus 6 into minus 2 on 3. The product is 4. Now we can form the polynomial. P of x is equal to x square minus sum x plus product. So this is equal to x square minus 20 on 3. The sum is negative and this negative is the negative of the expression. So don't make a mistake in writing that. Plus the product is 4. So this becomes x square plus 20 upon 3x plus 4. So this is the required polynomial. Other polynomials are of the form k times x square plus 20 upon 3 x plus 4. So you can write another polynomial by taking k equal to 3. So that is 3x square plus 20x plus 12. Both answers are correct. This is an alternate method of forming a polynomial when zeros are given. We know that a polynomial can be written as product of its factors x minus alpha into x minus beta. So if we know the zeros, we can find out the factors. So x minus alpha will be equal to x minus 6, that is equal to x plus 6. X minus beta will be equal to x minus 2 on 3, that is equal to x plus 2 on 3. So the polynomial p of x is product of these two factors, x plus 6 into x plus 2 on 3. Now multiply these two brackets. We get x square plus 20 on 3x plus 4. If your k is 3, then the same polynomial can be written as 3x square plus 20x plus 12. Question 3. If the zeros of the polynomial x square minus 5x plus k are the reciprocal of each other, then find the value of k. This is a different problem than the previous two problems. It's given that the zeros of the polynomial are reciprocal of each other. So let alpha and beta be the zeros. So we can say that one of the zeros, say beta, is reciprocal of the other, 1 over alpha. Therefore, beta can be written as 1 over alpha. Now, the polynomial is x square minus 5x plus k. From here we will write down the values of a, b and c. A is 1, b is minus 5, c is equal to k. Now let's use the relation between the product of the roots and its coefficient. So alpha into beta is equal to c upon a. Beta can be replaced as 1 over alpha. C is k in the polynomial and a is 1. So alpha and alpha gets cancelled. Therefore, value of k is equal to 1. Now looking at the question, one has to decide what is applicable here. We did not use the sum of the roots. There was no need to find a new polynomial because it is not asked in the question. You have to find the value of k. So we used the information that one zero is reciprocal of other, and we used product of zeros equal to c upon a, because when we substitute the zeros in alpha into beta, they will cancel out. So likewise, depending on the question, it can be decided what needs to be applied. Let's try question number 4. If one zero of polynomial x square minus 8x plus k exceeds the other by 2, find the value of k. Let one zero be alpha, then other zero beta. We can write it as alpha plus 2. It's given in the question, one zero exceeds the other by 2. So if one is alpha, the other is alpha plus 2. Now let's write down the values of a, b and c from the polynomial. A is equal to 1, b is equal to minus 8 and c is equal to k. Now we make use of the equations that relate the sum and the product of the zeros to the coefficients. So alpha plus beta is equal to minus b upon a. Substituting beta as alpha plus 2 and substituting b and a, we get minus 8 upon 1. So 2 times alpha plus 2 is equal to 8. So 2 alpha is equal to 6, alpha is equal to 3. Now we use the other equation, alpha plus beta is equal to c upon a. Substituting beta here as alpha plus 2 equal to substituting the values of c and a, k upon 1. Now here we have two unknowns, and that is the reason we use the first equation to find out the value of alpha. Now we can substitute alpha in this equation. So we get 3 times 3 plus 2 equal to k. This is 3 times 5 equal to k, and therefore k is equal to 15. Question number 5. If alpha and beta are zeros of polynomial x square minus 4x plus 3, then form a quadratic polynomial whose zeros are 3 alpha and 3 beta. The first thought that will come to your mind is to find alpha and beta from the given polynomial, then find 3 alpha and 3 beta, and then find the sum and the product and then form the polynomial. This is a long method. Though it is not wrong, it is long method. We can directly find the sum and the product that we need. The sum of these roots will be 3 alpha plus 3 beta. So in bracket 3 times alpha plus beta. Now from the polynomial, we can write down alpha plus beta as minus b upon a, which is 3 times minus a is 1, b is minus 4, and c is 3. So b is minus 4 and a is 1. So this is equal to 3 times 4. Minus minus becomes plus, so we get 12. So the sum of the required polynomial is 12. Similarly, we will find out the product. The product is 3 times alpha into 3 times beta. This is equal to 9 alpha into beta. And we can write down alpha into beta as c upon a. So from this polynomial, we can substitute c upon a, that is 3 on 1. So we get 27. So now we have the required product and the sum for the polynomial that we want to form. So polynomial p of x is equal to x square minus sum x plus p will be x square minus 12x plus 27. So we have got the polynomial. Question number 6. If alpha and beta are the zeros of the polynomial 4x square plus 3x plus 7, find the value of 1 over alpha plus 1 over beta. You may think that in this question we need to find alpha and beta by finding the zeros of the polynomial and then reciprocal and then add. You could do that, it's not wrong, but it is a lengthy method. 1 over alpha plus 1 over beta. Let's add these two numbers. So the LCM will be alpha into beta, and in the numerator when you cross multiply you will get alpha plus beta. So now we have the sum divided by the product, which is easy to substitute. Alpha plus beta is minus b upon a, and alpha into beta is c upon a. We will simplify this further. Minus b upon a, division will become multiplication, and we will reciprocal the denominator. So a and a gets cancelled. We are left with minus b upon c. So substituting the values of b and c, minus 3 on 7 gives us the answer. With this, we come to the end of this video lesson. Your assignment for today is exercise 2.2, question 2, and 2 more questions are given for more practice. Goodbye.